The automobile has been one of the single most revolutionary inventions of the 20th century, and without it, the world that we know today wouldn't have been as it is right now. It has paved the way for so much innovation, so much progress and development that we take it for granted. For today, we'll be taking a look back at the history of vehicle production, the assembly line, how it started, its humble beginnings, and how vehicles are manufactured today, as well as a glimpse into the future of automotive manufacturing. The story of the automobile begins with the original Ford Model T by Henry Ford, which began 1908 to 1927, where more than 15 million units were produced. Originally, before the assembly line, the people would work on one car at a time. Like each one team would work on a specific vehicle until it's finished. It was slow, so they decided to just try having a set of people do certain skills and move from one car to another and do that same job from one car to the next to the next to the next, where they specialize in their certain task. Like for example, if you're assigned to attach the steering column of one car, you'll be attaching the steering column of all cars, moving from one car to another. But still, that's still slow, 12 and a half hours. So if you see in this video, Henry Ford decided to, instead of having the people move around the cars, they're trying to have the cars move around the people instead. So this is their original experiment of the assembly line. And at this very moment where the cars started moving along and people working on it along the line, the assembly line is born, and this revolutionized manufacturing. As you can see, it's been really effective in cutting the production time. So they refined it, they made it even better. They tried putting rails, putting the car on rails so that it'll be easier to push. And as you can see, that it's been very effective. And they're also trying out the same idea of having an assembly line for the individual components of the cars. They're calling it the sub-assemblies, where a person would do only one thing and they'd be really good at it. Next, they did gravity-fed rails for the parts so that no one would have to wait for parts to arrive. They just roll towards them by gravity. And then after that, they also toyed with the idea of having conveyor belts in the factory. So with the conveyor belts, there's a constant speed of production now. People would be working as fast as the movement of the conveyor belt. And from that, it became more complex. Even engines are now being moved by conveyors. As you can see in the video, individual parts are being moved around. And now, instead of having the frame of the car on the ground on wheels, it now has its own assembly rail. This car was made between 1908 and 1927. That's a really long span, really long time span. From there, a lot of changes have been made to to improve, to perfect the assembly line. As you can see over here, the assembly line is way more advanced than how it used to be back then. This manufacturing method has brought the price of the cars down from $850 to only 300. That's a really big price decrease, and all thanks to the efficiency of the production line. So what happens after a few years? This time, let's take a look at another production line. This one is in 1936. And as you can see in here, they're much more automated now. They have so much machines in their factory shop, right, in the factory floor. Take a look at how well orchestrated all these machines are. In here, you see the machines bolting down the frames. This is a body and frame car. This is a ladder, a body and frame. This is the ladder chassis. and they get bolted together, and now they're putting the axles onto the vehicle. Tightening of the axles were still done by hand at this time, and now they're also lowering the engine onto the frame. And while they were doing that, the vehicle was moving forward on the assembly line. This area right here is the stamping area. Where over here are the stamp press machines. What they do is they stamp against the sheet metal to form the shape of the parts of the car, like the roof panel, the fenders. As you can see in here, they're making the side fenders for the car using the stamp to press the sheet metal into the shape of the part that they need. It is 1936. They weren't that focused on safety back then. Nowadays, you wouldn't be able to do something like this where you put your hand into the stamping press. That's dangerous. If your hand gets stuck there, your hand gets stamped. Now they're assembling the rest of the parts onto the frame. Over here, you see them putting the radiator assembly onto the front of the car, and now they're climbing into the car to bolt things down. They bolt the connections down on the side. They're putting the fenders on, all that good stuff. And now here comes the body. Like I mentioned before, this is a body on frame car. So the body goes on top of the frame. You'll see the unibody later when we look at a more modern vehicle, but this was back then. You see them lining up the body onto the car, and once it gets lined up, that's a lot of movement, that's a lot of wiggle. That's not really that effective. That could easily scratch up the paint and make rust-prone areas. But that's how they did it back then. It was 1936. So after they've assembled the body, the last bit is putting the wheels together. And now you see the cars look like cars. All their parts are in, and they're doing the final assemblies, the bumpers, and the other accessories. But the car is not essentially done. Now let's take a look at something more modern. And by modern, I mean a 2022 Hyundai Tucson. This is in the Hyundai's Alabama plant in the US, and we start with a roll of sheet metal. That roll of sheet metal is then brought into the stamping press. If you remember in the 1936 video, the stamping press is operated by humans, by people, and then human hands would grab into the stamping machine to pull the sheet metal out. This time, robots do all the work. And now, after sorting the stamp components, they're put together. So in before you had a body on frame construction where there's a frame and the body goes on top of it. Now this is a unibody car where the body itself acts as the frame of the car. So what the robots are doing now is that they're welding all the bits and pieces together. So you can see they're doing quite the job of welding the left panel and the right panel to the floor. And when that's done, they put the beams on the roof before putting the roof panel in. And in this clip, it now has a roof panel. The position of the roof panel wasn't shown. It was just cut to the chase because, well, it's just it. It's just putting the roof panel down. Now the machines are attaching the door. As you can see, modern assembly plants for cars are very heavily automated. Robotic arms are everywhere, doing almost everything. And not even the doors are manually assembled anymore. Now the car's being lifted. And now is for the inspection. Over here, you can see the person inspecting the quality of the work done by the machines, the robotic arms, if there are any defects in the stamping, defects in the welding, if the body panels are perfectly aligned. Because if they're not aligned, then it's going to be a quality issue. So everything has to be perfectly aligned, everything has to be perfectly stamped, perfectly welded. And that's what the inspector does. You can check the quality of the work. Okay. Now, after the quality of the work has been assessed, it's time to move on to painting the body of the car. But before going to the paint booth, the car has to be dipped in primer. It's way more efficient and overall better than spraying primer onto the vehicle because in here, every single nook and cranny of the car gets coated in primer. So you can see, not a single area is spared. All over the car, even underneath, every single fold, everything gets a fair share of primer. That prevents rust from happening. After the primer, the cars get sent onto the painting shop, the paint booth, where again robotic arms do the painting. No manual painting whatsoever. Everything is done by robots. That's automation in the workshop. Now, after the paint booth, people inspect again. They inspect the quality of the paint job, see if everything has been covered, everything has been done well, and then if there are any minor defects, all they have to do is just grab the buffer and just buff it out if there are any imperfections in the paint. Now that's done, time for more checks and inspections. Inspection is an essential part of the assembly line if you want to ensure the quality of the vehicle that comes out of it. Next, okay, here we have the assembly of the engine. That there's the engine block, and this person right here is bolting the cylinder head into the engine. And now here is the assembled engine going down the assembly line for more bolting. We're tightening the bolts onto the components and stuff. If you remember in the original Ford Model T, where each component has its own assembly line called the sub-assemblies, that was way back 1908 to 1927. But even until today, the assembly line, the sub-assemblies, we're still making full use of all those innovations made by Henry Ford back in the day. Because here, what you see is the engine sub-assembly, where a person does their job in assembling the engine, pass it on to the next, where that person does the next part in assembling the engine. Now, let's move on back to the car. Now they're putting the uh, essential accessories onto the vehicle. In here, you see they're putting the roof liner. The car now has protective panels to protect the paint. Now they're putting the bumper on. The tail light is now on. And here they're putting the fuel tank onto the car. Now keep in mind, each and every assembly line is different. Here you see the body is on top of the engine and suspension assembly compared to body and frame where the engine is lowered. This one in unibody, the body is lowered onto the engine. It's the other way around. Essentially, it gives the same result. Now they've been doing the interior and now they're putting the wheels on. As you've seen earlier, even putting the chairs in are done by robots. It's the modern world. It's 2021 and these cars are meant for the 2022 model year. So yeah, automation. Okay, the wheels are getting molten on. As you can see, the car is now taking its shape. As I've mentioned earlier, this is a unibody car, not a body on frame, as was shown in previous examples. Body and frame nowadays still exist, but they're mostly used in bigger SUVs, pickup trucks, cargo trucks, freight trucks, things that are heavy duty are body on frame. But for consumer vehicles like this one, passenger cars, most of them are unibody because they're more fuel efficient, they're lighter, they're more silent, overall more comfortable, and just better for passengers. Body on frame is more for toughness, for heavy duty. Okay, now back to this vehicle. You can see they're doing their final checks and inspections, and they're now driving it off the assembly line. Car is complete. But upon driving, a quick test on the suspension to see if that everything is working perfectly. So what about the future of car manufacturing? Where does the future lie? Well, with the current advancements in technology, it seems that car manufacturing is going the route of 3D printing for, especially in rapid prototyping, especially with the use of metal 3D printers, and the technology is still rapidly growing. 3D printing is a relatively young technology in the um, in its current stage. 3D printing is not new; it's been here for a long time, but there's still so much advancement to be done, and there's so many different kinds of 3D printing to explore, each with their own pros and cons. Like here, what you see here is a resin 3D printer using SLA or stereolithography. What was seen earlier was a metal 3D printer. It has it's for metal, and then there's also FDM or filament deposition modeling. What you see here, where filament is molten and deposited onto the print bed and forms the part. So as you see, there are so many different kinds of 3D printing. It's yeah, there's a lot to choose from, and each have their own uses. And what would 3D printing do for car manufacturing? Well, mainly, as I mentioned earlier, it's mainly going to be used for rapid prototyping. If you're researching, developing a new product, like a new design for something, improve on something, you're gonna want to have a quick prototype of that. Another purpose of 3D printing is for uh, a quick way to make tooling, casting dies. If you can make a large scale 3D printer, metal 3D printer, then you can essentially make your own dies for molding, for casting, for stamping without having to rely on traditional subtractive manufacturing methods. Because subtractive manufacturing has a lot of waste, and there's a lot of waste material because in subtractive manufacturing, you have a single block of material and you cut material away from it to get the final product. Meanwhile, in additive manufacturing using 3D printing, you add material, right? You start from nothing and you add material onto it. So you can see here, right? Material has been printed on, and now for removing the support material, trust me, I've tried it. Removing the support material is not a fun thing to do. It's really difficult. But yeah, once you've got the support material removed, you essentially have your part already. If you want, you can do more finishing to it, like in here, sandblasting to smooth the material. Because 3D printing is not exactly smooth, and this is a metal 3D printed part. You're gonna want it to be nice and smooth. Another purpose for 3D printing would be for custom making parts that are not that widely available, like for this. Like custom making a prototype,
Automotive dann ins Fahrzeug kommen. Das
Mhm.
heißt,
and you
man
can
zieht
see
die
here
Oberfläche aus dem
Okay.
Drucker raus, wird dann noch in
the engineers
verschiedensten
are
Verfahren
discussing
gepresst und
their
dementsprechend nochmal
prototypes that
gefinished,
they have
bevor
made
das
with their 3D
wirklich
printing to
einsetzbar ist.
see
Sehr gut.
to have a physical model to discuss changes on. But yeah, 3D printing is in the
Und
future of
Testverlauf,
automotive
wie man sie
manufacturing.
gerade in dem Fall benötigt.
So that will be all about my discussion on the past, the present, and the future of manufacturing and the assembly process of cars and automobiles in general. Thank you for watching, and I hope you've learned something.